Right, so we can get started. Hi, everyone. Welcome to the assignment review session for week 1 of Python fundamentals. So I hope you've got the chance to go over these problems that we are going to review today. This will be kind of a review on what we learned in the class, and also there will be a few new things as well that we may encounter, but those are just to show you a few more tools to solve problems. But the main theme of the class would be based on what we learned on Sunday class. So we will have multiple choice problems, which we're going to cover first. That's going to be very quick, just for a quick review on what we learned in the class, and not a comprehensive review. Is just a few quizzes basically, and then we're gonna go over some coding problems. So if you haven't seen the UI, I would highly recommend that you watch this video sometime after the class to see how the UI works. But we're also gonna use it in today's class, so that's also gonna be a good intro. All right, so what else? So most of these questions are basically borrowed from the LeetCode website. So when we tackle each one of these, we are not really, basically we don't really care about the optimization of the code. We just want to have some working solution. But for some of them that, especially if time permits, for some of them, I will also go over the, solution without using Python built-in functions and, trying to build up something from scratch. And some of them turn out to be an optimized solution as well. But that's not the, intent here really. We just want to make sure that we see, some application of what we had in the class. And then the other thing is that we don't have a TA in today's class. So, and usually I want this to be more interactive. So feel free to ask questions at any point. You have the Q&A and chat options, and whenever needed, if you feel like there's more clarity needed, please raise your hand and we can discuss further. So the class is designed for 2 hours. It may take a few more minutes. So in that case, if you need to, have a hard stop at the, after 2 hours, feel free to drop and then catch up with the recording. But I try my best to wrap it up on time. So I see there's a question in the Q&A. During this session, I also want to know more about the pivot index and how it's useful in real examples. So for these problems that we're going to solve today, please don't look for real world examples. These are basically, small, tiny problems that you may face in interviews, just to assess your coding skills and data structure and algorithms. So if there was any questions of this sort, please let me know, and I do my best to find some real examples for that. But it is not really the purpose of these problems. These are just some problems that you may face in interviews. That's it. All right, so let's get started with the multiple choice problems. So we have 10 questions here. We're going to cover them fairly quickly, and then we're going to get to coding problems, and we're going to spend most of the time there. All right, so the first question, how is a code block indicated in Python? So we learned that we need to define code blocks for many of the syntax that we learned in Python. For example, if you write a conditional statement, or if you write a for loop, or if you define a new function, later you'll see when you define a new class, we need to actually put that in a code block. And in Python, to to do that, we actually need indentation, which is basically the white gaps you need in the beginning of each line under that under the signature or header of that statement, whether it's conditional statement or if it's a for. So the right answer to this one is indentation, which is the way that you define the code blocks. So the next question is, which of the following types of loops are not supported in Python? So we learned about for loops and while loops in the class. For loop was to iterate through a sequence of items. We know what is the number of these items. So we have a finite number of elements that we're going to iterate through. And at each iteration, we're going to perform some logic or some procedure. And then we get out of this loop when the sequence is finished, unless we want to get out of that prematurely, which we use the break control statement, or if you want to skip some of the loops, you can use continue. We also had while loop, which would iterate until a condition is violated. And that was the main difference between the two. But that was all, right? So those were the only type of loops that we learned about and are supported in Python. So you may have seen other ways to iterate through a bunch of items like do while in other programming languages, but we don't have that in Python. So this option 3, is what is not actually supported in Python. Okay, so the next question is, what will be the output of the following code? So in this code, we have a couple variable assignments. So we have 2 integers that we're assigning to 2 different variables. Then we're going to print them. So far, so good. We know how to do every single of these things. And we know that print can have multiple arguments, and each argument will be printed out on the display with a white space in between the two. Then on the 4th line, something is happening which we haven't seen in the class. So that may be new. And actually, this is a topic for the 2nd class. But as a tool, it's good to know that if you want to swap the values of 2 variables, you can actually do that in one single line. Again, people coming from other programming languages may have not seen such scenario when they want to swap the values. Probably you have seen a definition of a temporary variable, and then which holds one of these 2 values, and then you can use it for the swapping. But in Python, you can actually swap 2 values in one single shot. And actually, what's happening here is this is called tuple unpacking. So what you see on the right side of this assignment is a tuple, and there's no parentheses, because by default, if you don't put any parentheses, Python gives you a tuple, okay, when you put items separated with commas. And then on the left side, you're actually unpacking those 2 elements in one entity into 2 different other variables. But it turns out these 2 variables have the same naming as these 2. So their values will be overwritten by the values inside this tuple. So we know about overriding. A variable with the same name can be overwritten multiple times throughout your code. So yeah, so this is what's happening here. But we're going to learn about tuple unpacking in detail on the 2nd week, next Sunday. So what happens here is we're going to print 5, 6 first, and then after the values are swapped, we're going to print 6, 5. Which is option 1. Any questions so far? I'm assuming that if there are any questions, you're going to put them in the Q&A tab or on the chat, but let me know if there are any questions, and I can pause at any point. All right, so the next question is kind of a simple assessment on our knowledge for conditional statements. So we had some sort of a similar example in the class. So what is the output of this code? So first, we are assigning a value to some variable with name age. And then on this line, our conditional statement begins. We have our condition, which should be a Boolean. If is a Python keyword, and if this condition is true, after the colon, our code block begins. If this condition true, we go to this part of the code or the block, and then we skip else. But if this condition is false, we directly go to else block. So in this case, we have 21 for age. This condition becomes true, and then we print eligible to vote. Okay, so that would give us option 2. I see there's a question in the Q&A. So this type of swap is only applicable to tuple? No, actually the answer to this question is no. You can also unpack a list, but usually when you don't put any parentheses or any square brackets or anything, that would be interpreted as a tuple in Python. And usually tuple unpacking is more common. When you, for example, want to return values from a function, by kind of convention, it is not to put any enclosing brackets or parentheses for them. When you see, when you get used to see more and more Python code, and this is what's actually happening. But that doesn't mean that you cannot unpack list variables. So, yeah. Okay, so the next question is, what is the output of this code? We have 2 inputs, which we are going to get on these 2 lines. So actually, there's a hint here that the input's going to be 5 and 6. So we get the input on these 2 lines, and then we're going to print A plus B, right? So does anyone want to tell us what this code will give us? Vijita, please go ahead.
50 or 5, 6.
Right, you mean option 2, right?
Yeah. Yeah.
And can you briefly explain why?
So when we do A is equal to input, it will, in the prompt is given 5. It is of type character or string. So when we do a print A plus B, it will be string concatenation.
Exactly. Yeah, that's exactly correct. Perfect. Thank you, Vijita. All right, awesome. So when we get the inputs, as Vijita mentioned, we will get them as strings, right? So that's by design. So that's a default. If you actually want to convert that from a string to an integer or a float, you have to explicitly typecast it as one of those data types. So here we are getting 2 strings, and then we know from class that this addition operator for strings is basically a concatenation. So A plus B in this case will be 5 sitting next to 6, right? So it's a string concatenation rather than integer addition, right? So this is not arithmetic, but a concatenation symbol. Any questions? All right. So the next question comes from the same idea. So we are given an input. The input is 1, 2, 3, 4, 5, and it's assigned to a variable named sentence right here. But we know that this won't be a number. It will be a string again. So it's basically a sequence of digits or characters like 1, 2, 3, 4, 5. Then we are printing something right here, which we'll see on the display. So this print is actually contains two parts. So we will have one object in the output, which is separated by a white space. First, we're going to see this string because it's enclosed in double quotes, and we can just print any string in the print statement. And then we're going to get the length. So this is the length function, and we know for any sequence of items, whether it is string or list, and later we'll learn about sets, tuples. We can use this len to get the number of the characters or items in that sequence. So the length of sentence in this case is 5. So we're going to see this thing and then a white space and then a 5 in the output. Okay, so option 2 will be the right answer. So I see a question in the chat. I think this is from the previous question. So the question is, in case of 5, if you choose 5.5 as input for A, would it become a math addition? The answer is no, because whatever you put here, it will be read as a string, right? So the input will become a string. So that basically, if you put 5.5, then the input will be the characters 5 and then a dot and then a 5, right? So 3 characters. When you add this to B, you will get 5.56. So that would be your final result. So no, unless you typecast it as a float, you will see still concatenation acting on those two inputs. Right, so the next one says which one is not a valid variable name in Python. So this is one of the hints we learned about in class. Actually, caveats, not hints. So we learned about variable names, and we learned that we can have letters, both lowercase and uppercase. We can have underscores and digits, right? So for example, you cannot put a special character in a variable name. But then even for those 3 categories, you cannot put the digits in the beginning of a variable name, right? So this is just a rule. So all of these things are fine. You can define them. But the last one, which begins with digits, is not allowed in Python. Okay. So the next question is, again, asking for the output of this code. So we are going into a while loop, and we have a counter, and we want to see what this print is going to give us in the output. So is there anyone who wants to actually walk us through these steps and tell us what will be the output? Abhinav?
Yeah, can you hear me?
Yes.
All right. Yeah, so I mean, this is the you initialize the count as 0 and putting it into an infinite loop of while true. So this will run till it breaks, and it will break when count is greater than 15. So
Yes.
if count modulo 3 is 0, then print whatever count is. So it's going to print 0, 3, 6, 9, 12. And because we are going to check for the break when count is greater than 15, it will also print 15 before it breaks. So it would be the option 4, 0, 3, 6, 9, 12, 15.
Yes, exactly. So yeah, the right answer is option 4. So one quick question here is, why do we use while true, and what happens if we don't have a break here when you're looping with the condition true?
Uh, so if I'm not sure about Python, but ideally it should break. It should sort of throw an Stack Overflow exception, reaching the upper bound of whatever the count is. I think int 32 it should be. So
Yeah. So basically, it goes in an infinite loop.
yes,
If there's no break here, right? Yeah.
that's correct. Yes, yes.
Perfect. Thank you, Abhinav. All right. Cool. So everything was correct, and I just want to give you a couple hints on this one. So first of all, this while true, it may seem a bit odd to use while true, because if you, for any reason, forget about breaking this loop, then we will have an infinite loop. But sometimes this is helpful, actually. If I want to give you some real example from machine learning or algorithms, so sometimes you're for example, in gradient descent or some optimization algorithm, you're tracking the convergence of some variables, and you want to let it go until some condition, some convergence criteria is checked somewhere in your code, and then you decide to break at that point, right? So you have two options. You can either use while true and let this algorithm go all the way until your optimization convergence criteria is met, or you can actually uh, put that, define a difference variable, and then put that condition here that when your difference is less than some threshold, like an epsilon or something, a very small value, then you're going to get out of this loop. So you have both of these options. But then in that case, you need to make sure that you update your difference variable at each iteration, which needs some caution there, right? So actually, you may see this in practice. So this is not that weird of a syntax. Okay, so I see there are a couple questions. So first, let's go with the raised hand. Vijita, please go ahead.
So I have a question about what you just said in explaining about why while true versus putting in the condition in the while. So I don't see how it will make a difference. You know, you were explaining that you have to use it because the count needs to be incremented either way, whether we do the condition there or inside. So how would it make any difference?
It doesn't really. So as I said, you can have true here and then decide when to break out of this while loop, or you can actually put your condition here. But when you put the condition here, then you need to make sure that maybe your condition is not based on count, is based on some function of this count, right? And that could very well be the case. In that case, you need to do some extra work to make sure whatever variable which is your criteria for convergence, so that should be updated, right? Otherwise, you have both options.
Okay.
Yeah.
Thank you.
Yeah. Thank you. I see there's another question. Sukriti, please go ahead.
Yeah, hi. I don't have a question, just a quick comment. So generally, like what I've seen, we have for while true, we have this use case when we do some kind of polling, right? Like we are polling for a file, and we don't know how many times it will like execute or iterate. So this is like another use case we use for while true. So like once the file is available, we get out of the loop. Right? So just wanted
And
to share that.
so that's a great example. Yeah, thank you for mentioning that. But then the question is, what if the file, because we don't know when the file is going to be available, we need to set a
Yeah, we
set.
have a timeout actually. We have a
Yeah, we should put
timeout.
some
Yeah,
time out.
yeah.
Exactly.
So that's kind of like the breaking step.
Yes. Yep. Cool. Thank you, Super. All right. So, and I see there's a question that what will be the result if this was a continue instead of a break? That's a good question. And then what happens is that we never get out of this loop, right? So if this is a continue, then after count becomes more than 15, for example, it becomes 16, then we continue, which means that we don't increment count. So count stays at 16. And then we go right here, we print nothing. And then at this step, we continue again. And this will actually go in a loop, right? So nothing really happens and we get into an infinite loop. Yep. Yeah, exactly. So if you're using some cloud platform, then as Jeffrey mentioned, your bill will go up in that case. Right, any other question? All right, so let's actually get to the next one and let's wrap it up and then get to the coding problems. So this question is trying to basically assess our basic knowledge of lists. So we are given this list. So we know it's a list because these items are enclosed in square brackets, and we have multiple items separated by these commas. And then the question is, what is the value at index 2 in this list? So we know we start from 0, and then 1, 2 gives us this third string or a green. Okay. And then the last question, what will be the output of the following code? So we are given a list, and the list is multiplied by 2 in some sense, or the star operator is actually applied to this list with duplicates of 2. So what this means is concatenate this list by itself 2 times, right? So 1 and 2 will give us option 4. Okay. So don't get this confused with matrix operation, where multiplying by 2 gives a multiplication by every single element in the matrix, which gives you option 3. So that is something which we'll actually see on the last week of this class, which is Python for ML. And you're going to learn about NumPy. And there you're going to learn about broadcasting. So if this was a NumPy array, by the definition of broadcasting, this would give you another NumPy array with all the values multiplied by 2. But this is not a NumPy array. This is a Python list. And this operation means multiple concatenations. So this is what we get for this question. All right. So I see there's a question in the Q&A that what's the best practice in Python to define a string literal, double quotes or single quotes? So the answer is that there is no preference really. Actually, we did have a have an example in the class, if you remember. So we don't have a specific preference. You can use both. The only thing is that if you want to use, actually you want to, let me actually go to this here. So you actually, let's say, want to define a string and some random string, and inside your string you want to actually use double quotes. So you want to see those double quotes in the display. So if you use double quotes for both purposes, then the way Python interprets this, or I guess any other language, so these two are matched together, and these two are matched together. So this part of this substring in between will be undefined because it's not a part of any of those two strings. So it will give us an error in that case. So if you want to actually use double quotes inside your string, you should either make it a special character, right? And then maybe I can also print it here. You can either do this by using special characters, or you can turn this or define the string with single quotes, so that now this is the original string, and this is the part you want to actually put in quotes. Okay, so both of these are, you can do both of them. All right, any other questions from these multiple choice problems we've seen so far? So the question is, so the star operator is how many times will it concatenate for the last one? So if this is a 2 here, it means that concatenate A with the same A 2 times. If it was 3, then it would do it 3 times, right? So if I print this here, because it's 2, you'll get 2 times concatenation of A. If this is 4, then you'll get 4 times concatenation, the same list. All right, so if there are no other questions, let's go back to the problem set, and let me reset my previous code. All right, cool. Okay, so this is how the UI looks like. This is pretty similar to the LeetCode UI, a bit simpler, I'd say. So on the left side, you see the description of the problem and some examples of what is the expectation. And down here, there are some notes and some constraints that you need to be aware of when solving this problem. And then you can see the question here. If you run your code, you'll see the information of the runs here. And then these are your attempts, historic attempts. You can go through your previous attempts and see, whatever information. So what was your solution? How much time it took for you to solve it? The execution time, memory. So we're not going to look at these numbers in this class, but these are the things that you need to optimize in your interview problems. And yeah, so and then the solutions, probably you have access to some solutions for these problems, but actually I'm going to share with you a notebook which has some other solutions as well that I assume it's not on these solutions. But then on the right side, you can write your code. So you have a function here, which is going to be basically the assessment would be on this function. You write your code here, and you will return the values right here. And then after you run this code, it will show you if your code passes or not. So you choose your programming language, and then click on run. You have a few options. You can actually have your custom input, or you can use the tests or test cases that are designed for you. You have multiple of those, but if you want to make this a quick run, you can click on the quick test. Okay. All right. So now we are going to go over these problems. So for most of these problems, I'm going to show you one answer which uses Python built-in functions. For some of the questions, I will also go over the basically writing this from scratch without using Python built-in functions. Okay, so you may ask which one is more prepared. I would say most of the functions in Python are optimized for these use cases. So if you have the option to use them in your day-to-day work, please do. That makes your life much easier. But if you're at an interview, then in most cases, the interviewer wants you to know how to write these things from scratch. That is not the focus of this class. You're going to learn a lot more about that on data structure and algorithms. But we're going to go over some of those to actually have some more practice on what we learned in the class. Okay, so I see there's a question that get to know that in order to count the solution as an attempt, I have to run the full test only. Yeah, I mean, I would always encourage to run the full test because sometimes some of these, all of the quick tests pass, and then you run the full test, you realize that some of them will not go through. So I always recommend full test, but in the class, because we want to save time, we go with the quick tests. Okay. All right, so the first question is reverse a given list of numbers, reverse an array. And by array, it basically means a list. So let's say we are given a list like this with 5 elements, and then we're going to reverse it, and it comes with the from the title, right? That what we should do. So the first element goes to the end, and then the last element goes to the beginning, and so on, right? So we basically reverse the order of these elements. The note says modify the input array in place and return the modified array. So basically, we don't want to create a new array. We want to modify our current array in place. So if you remember from the class, we had multiple built-in functions for Python lists, and one of them was reverse, right? So this is something we're going to learn more about on the third week, how to do custom sorting and how to include reverse in those. But we can also use it for, now we know how to use it, so we're going to use it as an in-place operation for this given list. So the list is named nums, the input list, and I just put nums.reverse, and that will basically reverse the order of the elements in nums, and I will basically return that nums. Okay. So if I do a quick test, then you see what happens here. So we have 6 test cases, and it's loading now, and then it's gonna show if my solution works or not. So you see that all the test cases pass, they're all accepted. And then these are some information about those cases. And then if you click on any of these test cases, you'll see what the example was. So this was the example, the input. This is what our code results, and this is what the expected result is. So that's why it passes. Okay, so I'm gonna show you another solution to this one, but before that, I see there are a couple questions. So the question is, How about we keep 2 pointers, I and j? So I'm going to go over that solution next. That's right. We can use 2 pointers for this. The other question is, one difference between a list and an array, as I understand, is that array size is pre-declared, which makes an index-based lookup an O1 operation. In Python, looks like lists and array are used interchangeably. Is that the case? So the answer to that, if I want to answer this shortly, we do have an array definition in Python too. We are not going to cover that in this class because that's kind of a structural change in the data types or data structures. But what you mentioned this is correct. But the thing is that lookup based on index is also a constant operation for lists, but a search is not, right? Even if the length of the list is dynamic, but it's still gonna be a O1 operation to find the elements of the list based on their index. All right, so now let's get back here, and I want to show you another way to solve this thing. Okay, so for the second one, I'm going to show you a technique which is called 2 pointers. And what it basically means, if you haven't seen it before, it means that, let's say we have this list and we're asked to reverse it, right? So what I'm going to do, if I'm not going to use built-in functions in Python, I'm going to put 2 pointers. So let's say I and j, or left or right. The naming doesn't really matter. So I'm going to put 2 indexes. One is L, or left, and one is R, or right. And then each time, these indexes are pointing to these 2 elements. So each time I get to this stage, I'm going to swap those values. And now we know how to swap elements, right? So if I do the swap, the new list would look like this: 17, 50. And now we need to get to the rest of the elements. So L, or the first pointer, will go one to the right, and R goes one to the left. So these 2 pointers keep moving and get closer to each other. And at each step, they're going to swap values. So this becomes 66 and 35, right? And then L goes one step to the right, R goes one step to the left. And as soon as they get to the same spot, or they pass each other, right, then we're going to stop the run, or stop the algorithm. So that's what we're going to do. Okay, so let's see how this works. So we're going to begin. Let's comment this out. So we're going to begin by initializing L and R. So L is 0, and R should begin from the last element of this list. But we don't know how many elements are there in nums. So we cannot put a number here. What we do is we get the length of nums -1, because in Python we start from 0. So if we have 5 elements, the last index would be 4, right? So it would be 1 less than the length. Okay. All right. So first we initialize these variables. Now to go into this step-by-step setup, I'm going to define a while loop, because we have an iteration here, right? So we have an iteration where at each step we are performing some operation, right? So while L is less than R, so as long as L is to the left of our second index R, we are going to continue doing whatever goes into this block. And as soon as this is violated, we're going to jump out of it. Okay. So the first thing we're going to do is we're going to swap those elements, right? So nums at L nums at R, we're going to swap them by R and L, right? So that's the first thing we do. And then after these two elements are swapped, then we are going to increment L by 1 and decrement R by 1. So L goes 1 to the right and R goes 1 to the left. Okay. And this is gonna keep keep going until L and R are this condition is not satisfied for L and R, right? So L goes gets equal to R or gets past R. In that case, we're going to get out of this while loop. And then the last step is just to return this list. Okay, because now all the values from both ends are swapped, and we keep doing this until the full list is reversed. So I can also try this quick test. Okay, any questions? So I see there's a question in the chat that is nums.reverse equivalent to nums equals nums reverse? The answer is no, it's not equal because nums.reverse is a built-in operation and it's going to return none, right? So what you're asking is, so let's say nums is these few elements, and then nums.reverse is gonna change that nums, right, in place. So what happens if I print this thing? It prints none, right? It will reverse nums in place, but if you try to print it, because it returns nothing, it will return none. So if you assign this thing to nums again, it will assign none to nums. So nums becomes none. Nums becomes none. Okay? So keep that in mind. Any other questions? So there's a question to repeat this again. This operation is in place, meaning that after you call that function on a list, it's not going to return anything. It's going to make some changes in place to this object. So if you try to print the outcome of this thing or the returned value, it will be none because it doesn't print anything. So after this cell is executed, then this list will be reversed, but this thing is not returning anything, right? So there's another question that does reverse internally uses the same swap mechanism we just walked through. So I don't know exactly the exact implementation under the hood that is used in Python, but I assume yes, because that's probably the fastest way, the linear way to do this. It should be something very similar to what we just saw. Okay, so let's go back. Let's go to the next question. And I see there's a question about the previous one. So in line 8, how was it reserved already? So you mean line 8 here? So because I'm running this cell, this part is already reversing it. So it doesn't mean that it won't reverse, right? So you're printing it, it is returning none, but it is doing its work, right? So it is still reversing this list. So that's why you see a list reversed already on this line. Okay. Okay, so let's go to the second problem. Let me reset my code. Okay, so this problem is asking to insert an element at a specific position in an array. So given an array of numbers, insert a given element at a specified position in the array. So let's say we have this example. So we have these numbers, and at position 2, we're going to add element value 3. So now the trick here is that when it says position 2, in this problem, if we go down to the nodes, so first of all, the last element of the array is -1, which indicates a blank position. So forget about this -1. So what we're going to do in the code is we're going to pop it out at the end. So it's just showing the terminal state of the list. So forget about that. And then the given position follows 1 based indexing. So this is the trick here, right? So the trick is when it's asking you to add an element at position 2, it's basically 1 based indexing. So instead of starting from 0, you should start from 1. So it will be 1 and then 2. So here's where we want this new element to be added. So it will be 2, and then we have to put 3, and then 4, 5, 6. So this is how the final output will look like. Okay. So the next example is insert element 40 at position 4. So we have 1, 2, 3. So we put 40 right here, and then -1 will be popped out at the end. Okay, and then we're asked to return the modified array. So we're gonna modify this array and then return it. Okay. All right. So we have seen the insert method in class, and that's a built-in Python function. And if we use it, life would be very easy. So we can just write nums.insert, and then insert. You should put the position first and then the element, right? So we have elements, we put it here, and then position would go here, right? So this is how we learned this in class. But the thing is, insert works based on 0-based indexing. But now the position we are given here is asking us to put it on a 1-based indexing. So let me show you an example on how insert works. So let's say here we have these nums, right? So I write nums insert. I'm gonna put a 5 at index 2, right? Now, if I run this again, so you see 5 instead of here is added here, which means starts from 0, 1, 2. So it's added right here. Okay. But the question here is asking us to do a 1-based index, which means start counting from 1, and then 2 will be this one, right? So what can we do to address that? The thing we can do is whatever position given to us, to make sure Python understands that 1-based indexing, we just put a -1 here, right? We just move it 1 to the left. In that case, now, oops, actually I need to pop out this 5, which was there from the previous example. Let's actually do that. This is nums. Here now 5 is added as position 2, right? So it was supposed to be 2 with 1 based index. We need to subtract it by 1, and then we will get this. Okay, so now that we know what's going on here, we know why we should put a -1 after the position. And then the last element here is just showing us the terminal state. We just pop it out. Let's just put a nums.pop, and it will throw out that -1. So there's not a particular reason we have that there. So if you have seen linked list, usually we show a terminal state, -1. And I guess this question is basically coming from, I mean, originally was defined probably for, a linked list type of problem, maybe. And they have kept this -1 at the end. So we just pop it out. Okay, and then we will return nums. Okay, so this was one way to basically solve this problem. I'm going to show you another way, again, by writing this thing from scratch. But before that, are there any questions? I don't see anything on the chat or Q&A. So our solution is passing all 4 test cases. You can try this in the meantime. So now let's go back here. So this is our first solution. Now I'm going to show you another one. Okay, so the next solution I'm going to show you is actually creating a new list. So I remember the question, return the modified array. So the question they're asking to modify the array in place. But yeah, so what I'm going to show you is not changing the array in place. But actually we can do that. I'll give it to you as an exercise to see how you can actually do this in one single array. But let's actually see my solution first. So I'm gonna create another array. Let's call this new nums. It's gonna be a new list. Okay. So I'm gonna go through all the numbers, and when I get to that in a particular position, I'm gonna insert that number, and then I'm gonna move every other number after that position one to the right, or I kind of adjust the index based on where they are, right? So let's say, let me show you an example here. So let's say we have this array here. So let's say we are asked to put 3 at index 2, right? So let's forget about this one. So I'm at this index, I'm looking at this one. Is this the right index to put 3? The answer is no. So I'll add it to my new nums. So my new nums is empty. So I add 2 here. Then this will go to the next one. So this is index 1, which from a 1 based indexing, it is actually index 2. So I'm going to add that given element 3 here. And then this goes to the next one. So from the next step, I'm going to add the one before the current step. So if the index is here, because we are past the position, I look at the number in the previous step because I don't want to miss that. And then this will go to the next one, and we'll take the number from the previous step. And this is basically why we need that -1, because now this pointer needs to go to the last terminal state, and then we're going to get all the numbers one by one. So this is the trick that we're going to use. And then we don't need to pop out anything, right? So because this is the terminal state, and we're not going to go anywhere after that. Okay, so for I in range of length of nums. So you remember the syntax for for loop, for variable name in the range of these values. And whatever this length of nums is, in this case, let's say we have 5, it goes from 0 to 4, right? So we have some conditions. I want to write some if and else to check if you're at the this given position, right? So if I is, let's say, if we are actually at the position, and we also need to put a -1, right? Because of the same reason we had a -1 here. If I is at position -1, then we have to append that, right? So we have to append that element to our list. So if we get to the position which we're gonna have to insert this, we just insert that at that point. Now the other condition is what if, or maybe I can actually write this this way. First, let's say if I is let's say less than position, right? So if I is less than position, then we are before that position. So new nums that append whatever the current index at that nums is, right? So before the position, we just keep piling up those numbers. So we will append nums at I, and then when we get there, we're gonna append the element. Actually, this has to be position -1, right? Because if it's position -1, then yeah, so this would not go through. Okay, so this has to be elif, and then finally else means I is greater than or equal position, right? So in that case, we have new nums append. So we have to keep adding the elements in our array, but now with one shift to the left, because after we have populate that position, now we need to go and look one step back to make sure we keep all those elements, right? Okay, and then at the end, we're going to return new nums. Okay, so let's check to see if this works. I think it should, but let's check it out. Any questions? Okay, so it's passing all the test cases. So I see there is a hand raised. Abhinav, please go ahead.
Is the overall asymptotic complexity better than reverse, or are we just trying to, or then insert, sorry, or are we just trying to not use the built-in function? Because here also we are using obviously append. And my other question is, could we have just not updated the index itself directly, as if new nums of I -1 equals to nums of I, rather than saying new nums dot append?
Yeah, so answering your second question first, the answer is yes, you can do that. So I'm gonna give it as an exercise. So what you need to do each time you go to the next element, you have to check to see if you're at that position or not. Then if you are, then you basically replace that value with the element, and then keep that value somewhere in some temporary container, right? So some variable, and then you keep doing that each time you go to the next value. So you swap those values, and then you keep this in the temporary, then you go all the way to the end. Okay, and then you probably need to pop this last element. Now, getting back to your first question, there shouldn't be any time complexity difference between these two. So again, I'm not sure how exactly the Python index or insert is implemented, but what I know is it's basically should search for this position and then place it at that position, right? So it may be a little bit more efficient using Python, because I know that there's some linked list implementation involved in the definition of lists in Python, but I'm not sure about that, so I have to double check. So usually Python functions, from what I've seen, they're very efficient, especially when we get to searching and sorting. They're quite efficient. All right, I see there's a question. Is it possible to have this class started at 6:30 instead of 6 to allow some of us to commute back home in time? So that is not in my control, really. So you need to reach out to the ops and organizers, but there's nothing I can do for that. I think there has been quite a few years, actually, at least from the time I joined, that the time of this class have been fixed. And even the days that I need to change the time of the class, they do not allow me, and they find replacements for instructors. So for example, the last class in this series, I'm not able to make it for that Sunday. So they didn't allow me to do it on Saturday. So I think they're pretty strict about, at least for Python fundamentals, they're pretty strict about the timing of the class. So, all right. So let's go to the next question: intersection of two arrays. Okay. So let me clean out. So the question is, given two lists of numbers, find their intersection. Okay. Let's say we are given these two lists. So what is the intersection? So it means common elements, right? So for example, 4, we only have it on A, but we don't have it on B. So it's not in the intersection. But 2, we have on both. We have 2 number of 2's on A and 3 number of 2's on B. Because it's looking for intersection, we take the minimum, right? So we take these 2 because this one doesn't have any other 2's. So we'll get 2 2's here. And then same thing for 3. Both of them have 3, but the first one has only 1. So there will be 1, 3 in an intersection, but there's no 1 in the second list. So 1 is not part of our common set. And the next example, the intersection is empty because there is no intersection between the two lists. Okay. So some notes here: the order of elements in the output does not matter. So that's first. And then the frequency of any number in the intersection must be equal to the minimum of the frequency of that number in both the given lists. So we mentioned that as well. All right. So let's see how we can solve this one. So for this one, we have some solution that I'm going to go over right now, which is probably not the best solution, but it's based on whatever we've learned so far. There is an efficient or more efficient way to solve this problem, and that is using a dictionary to get basically the counts, or using a counter to find the counts of these elements in each of these lists. And that will be a better solution from an efficiency viewpoint. But let's go over the first one for now. And then the next one, I'm going to actually share the solution with you. After we learn about dictionaries on Sunday, you can actually go over that solution on your own. So what I'm going to do is I'm going to begin with the intersection as a list, which I'm going to keep populating as I see an intersection. in the lists. Now, I'm going to actually do a trick. After I see any of these elements, so we're going to iterate through one of these lists. And when I see that element in the other list, what I'm going to do, I'm going to actually remove that from that list. So what happens in this case is, if I remove that, then I won't be able to basically see that element anymore, and I'm going to get the minimum number of these numbers, right? So let's say you start from, let's say you're iterating through B, right? So you look at the first element, it is 2. Is 2 an element which also exists in A? The answer is yes, right? So then 2 will be part of your intersection. You go to the next element. If I don't remove this 2, now we have another 2 here. Is it a part of intersection? The answer is yes, because we have a 2 here. And then we go to the next 2, and again, the answer is yes. So we have 3 number of 2s in our intersection, but that is not right. Okay? So that's why each time I see an intersection element, I remove that from the other list, so that after 2 iterations, I'm not going to see any more 2s there. Okay? So if I don't want to change that original vector, then what I do is actually I make a copy of that. So b copy is b dot copy. So we learn how to copy a list, right? So we will make a copy of it, and then for let's say we're gonna go through elements of A. Let's say for number in A, so we go through A one by one, right? And each time we see an element, we check to see if it exists in the other list, right? So if num is in B copy, then if that's the case, then it means it is in our intersection, right? So intersection dot append num. And what we also need to do is we need to make sure that we remove that element from this copy, right? So the copy, we learned about the remove function, and we want to remove the first occurrence of num. Okay. So after this, we can simply return intersection. Okay, so does this make sense? So this is not an efficient solution at all. And I suppose if I run this, we'll get some error, execution time error, but let's see what happens. Okay, so most of the test cases pass, but for this last one, it says time limit exceeded, which means your code is so slow that if the number of inputs is big, then it cannot handle it on time. So if I show you how this input looks like, you see that this is a huge vector with tons of numbers in it, right? So if the code is not efficient, it cannot really handle these kind of scale. So I'm going to share a solution with you which shows you how to do this in a more efficient way. But why is this solution so complicated and not very efficient? The reason is that you get through each single element of A, right? And then each time you do that, you also check to see that number exists in B, right? So this is not efficient because you're checking an existence inside a for loop, which is making this double linear or n squared solution. So this is a nested something similar to a nested operation for loops. What you could do instead, you could actually go through each of these arrays in a linear way and get an understanding on how many items each of them have, get a copy or basically a record of each of these items and how many times they're repeated in these lists. Okay, and then you could go through those, which are probably smaller sets of items, and then check to see if there are any common values, and if there are, what's the minimum number. Okay. Okay, so let's see if there are any questions. Can we use element I, num, or any other letter word in loop to represent elements? Yes, you can do that. Actually, instead of for num in A, I could do for I in range of length of A, and anywhere you see num, you can use if A at A at I, right, in B copy, and then for each of these num, you have to also put A at I. Okay, so this is how we can use index for this for loop rather than the value directly. There's another question that is shallow copy good enough here? The answer is yes, because the values inside these lists are all integers. There's no mention anywhere that we're going to use another list in this list, for example, or anything like that. So we should be good. Otherwise, we need to do a deep copy to get a independent object. So I see there's another comment in the chat. We can use count of each element and then get the minimal matching count and return that answer. So yeah, actually we can also do this with count, but that is also inefficient, because each time you're counting something, which is a linear operation too. But yeah, feel free to try it out as an exercise. You can definitely do that. So we are actually going to use counter for that, which is a way to do this using dictionaries on the other solution. But I'm going to let you go over that after we learn about dictionaries next week. All right. So any other questions on this one? So the question is, why do we need a copy here since we don't use B later in the code? Is it always a good practice to do a copy when you remove from a list? The answer is that's a very good question, and the answer is no, really. There's no preference. You can actually keep using B instead of B copy, but the cost here is that you're going to lose B. If for any case you're not supposed to touch your original lists, then it's better to make a copy and play with that copy, so that's why I'm using a copy. But otherwise, you could simply use B, and actually it will go through and nothing will really happen. Any other questions? So one argument here, I see there's a comment that one argument could be that it would help with logging, keeping the original and using the copy. Yeah, right. So if you want to later use that original value in logging, and by logging we mean the reports that you want to publish from your code, then you can actually keep that to make sure you have both values. So that's one thing. But yeah, it's based on the use case. So it totally depends on the application and the use case here. All right, so let's go to the next one, find pivot index. All right, so the next question is, given a list of integers, numbers, numbers is the list of integers, calculate the pivot index of this list. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. If the index is on the left edge, then the left sum is 0 because there are no elements. This also applies to the right. Return the leftmost pivot index. If no such index exists, return -1. So I think the question is pretty clear. If you want to take a look at an example and see what it means, we're given a list, we want to find the pivot index. And it means that for that particular index, all the elements to the left should sum equal to all the elements to the right. Okay? So for example, here, if you look at these, and the pivot index, you could have multiple pivot indexes, but you're looking, you want to find the leftmost pivot index. So for example, here, this element is a pivot index because all the elements to the left sum up to 5, and all the elements to the right also sum up to 5. So this is a pivot index. But this one is also a pivot index because all the elements to the left and right sum up to 6, but the answer would be this one because this is the leftmost. So these two are not pivot indexes. So this would be the answer. So 2 means index 2, 0, 1, 2. So that would be our answer. So here we don't have any pivot index. We just return -1. And here we have a pivot index, which is this one, right? Because to the left, we have no elements. So the left becomes 0, the sum of the left elements. And then the sum to the right is 0 as well. So this becomes our pivot index. Okay. All right. So our solution for this one is to use slicing that we learned in the class. And what I'm going to do is I'm going to go through all these elements one by one. And each time I get to some element, I find the sum to the left and the sum to the right. Okay. So I'm going to write a for loop for I in range length of numbers. And I'm going to find the left sum. Then I'm going to find the right sum. So I'm going to show you how to find them. So not yet, but I will show you how. So we know what the left sum is and then what the right sum is. If these two are equal, if the value of these two are equal, then we're going to return the index which makes that happen. But if that's not the case, when we get out of the for loop and we cannot find that index, we're going to return -1. Okay. Now, let's see how we can find the left sum. So we're at index I. We want to find the sum of the numbers to the left of I. So the numbers to the left of index I will be, we can found it using this syntax right here, right? So we have a slice of numbers which go from the beginning. I can also put a 0 here, but I also can put nothing. From the beginning to index I, and I is exclusive, which means to the left of I. And I want the sum, so I put the sum around this thing. So we also have right sum, which is the sum of numbers, which should go from I plus 1, because the first index is inclusive, all the way to the end. Okay. So this should give us the answer. So this was one solution to this problem. And at each step, you are finding two sums, right? So these can be actually improved. Oh, actually, there seems to be an issue with my solution. Yeah, I see that instead of range, I'm putting RNH. This should be range. So let me make sure that this is the issue. Yeah, so the issue is that range has a typo. So let's try it again. So yeah, I was saying that we have two sums here, but we can actually improve this solution and make it more efficient by using only one sum. We can actually find the sum of the whole list. And then as we move into steps one by one, we keep track of the elements that we have seen so far and keep a sum from the left. At each index, we can now find the sum from the right by subtracting that whole sum from the left sum. So that is a more efficient solution because we are finding the sum of these numbers only once. So I'm going to give you that as an exercise. So later, try to actually get a solution where you don't find sum in 2 times at each step. You only do sum of numbers once. And then as you move through this for loop, you keep track of all the elements you have visited up to this point, and that will be your left sum when you need it. And then this thing minus that left sum will give you your right sum. Okay, so get this idea. If this was not clear, please watch the recording and try to solve this on your own. So some learners ask me, how can we get better and better at this? How can we get comfortable with these concepts? These exercises will help you get more comfortable. There's no other way other than practicing a lot of different problems to get better at these concepts. So I'm just showing you some basic solutions, and think of it as a starter. But it's up to you, how much you want to get progress and how much you want to get comfortable with these topics, and if you actually want to do it yourself, not just auditing these solutions. And we don't have enough time in this class to go over all the possible solutions, so that's why I give you some of these as exercises. Okay, so before I go to this one, any other questions about this problem? Okay, so if there are no questions, then let's go this one. All right. So this question is reverse words in a given string. So given a string S, your task is to reverse the words of S. So for example, if you're given this list of strings, we're going to reverse it. By reverse, we don't mean to reverse it letter-wise. We want to reverse it for words, right? So the first word becomes the last, and so on. Okay. So we did reversing on the first problem in this set. But now we want to do that for a list of words. If there's only one word, then the reverse would be the same, right? Okay, so what I'm going to do first is I'm going to use Python built-in functions for this. So my first solution would be using what we learned in the class, right? So we learned about the split function, and we know that the split will give us a list of words if you're given a sentence, right? And it finds the words based on the white spaces. So if we are given string S, then we can use split to do s.split, and let's actually put that in a list named words. So now words becomes a list of strings, and each string is one word. Okay. Then we know how to reverse it. So we have words that reverse. which gives us a reversed list of words. And then we know how to join them back into one sentence, right? So final sentence would be, so we want to join them with a white space. So we have white space dot join, and then the input here would be words. So if you don't remember this syntax, please take a look at our notebook from Sunday class. But we learned about all these methods in our class, right? Okay, so after this, we're gonna get the final sentence, and we just need to return final sentence. Okay. All right, so any questions of this one before I go to another solution for you here? So I see there's a question that, can we use enumerate in this case? The answer is, you can always use enumerate if you want to do a for loop. It's just the matter of how you would need it, right? If you want to use a for loop to solve this problem, and actually I'm going to show you a solution using a for loop, you can actually do that. But I'm going to actually use the range in my solution because I want to show you a trick. But feel free to try it out and see if, how you can use that. So let me show you a solution with basically the for loop. So this one is let me see how to, actually this one is a little bit tricky, but I'm going to show it to you anyway. So in this solution, I'm not gonna use any Python built-in functions. I'm gonna go letter by letter, right? And then how I'm gonna do this is, I'm gonna start from the beginning of this sentence, and I'm gonna go character by character. And then as I see these characters, I'm gonna do, actually, this is gonna be my, let's say, my final string, right? So I'm gonna start by the first character, and I'm gonna put it right into this. And then as long as I'm not hitting a white space, I'm gonna put the next character concatenated to the beginning. Oh, sorry. So I'm gonna put the character next, and all the way until I hit this in this white space, right? As soon as I see the white space, then my next word would be this one, technical, which is gonna be concatenated from the other side, right? So from the left side. So this is how I'm gonna build this. So I'm gonna start from the first word, and then the second word is gonna be concatenated from left to the first word. Okay. So this one is interesting because we're just simply gonna use a for loop and the fact that we can concatenate the string. So we're not using any Python functions here. So let's say I have final s, which is an empty string. And then I have another string named word. And the word is the placeholder for me to actually keep track of words one by one. This is going to be my current word, right, that I'm looking at. And what I'm going to do is I need to actually add a white space at the end of my given string. And I tell you why. So let's say I just put it here right now. But if I don't put a white space at the end of this given string, then basically, what happens is that we don't know when to actually end this. So let me actually show you how it works. At the end, we're going to see an example. So for character in S, so I'm going to go character by character in our given string. So getting back to the previous question, is there a way to use enumerate here? Probably. So we can use for character and for index and character in enumerate of S, right? So this is what we can do if you want to use enumerate. But we don't need that because we don't need index in this solution. So I'm gonna keep using character in S. So what I'm gonna do is, as long as I'm not hitting a white space, I'm gonna keep completing my word, right? So if the character is not a white space, then keep adding characters to my current word, right? So I'm gonna keep tracking. For example, if I start here, I'm gonna complete this word until I get to this white space. Now, what happens if it is a white space? So in that case, I know I'm at the end of the word. So I need to check if the word is non-empty, then I'm gonna concatenate it to whatever I had from before. But otherwise we're just gonna get out and return that string, right? So if word is not empty, then the final string would be this word that I just created plus or concatenated with a white space and whatever we had so far for our answer, right? So let's say we already have this best, then we find this technical, and then we want to concatenate this technical from the left side with a white space and then best. Okay. And then after we are done with this for loop, then, oh, by the way, after we do this, then we want to refresh the word, right? So we need to make sure it's empty again, because now here we're gonna compile the next word, and at the end we just need to return our final S, but we need to make sure that the white space is also removed. Okay, so let me show you what's happening here. So let me actually go over one example step by step. So let's say this is our example, right? So best technical interview prep courses. Let me actually put that here. So this is our S. S is this thing here. Okay, so going through this, final S would be an empty string. Word is another empty string. And we're going to add an empty space here, for S at the end of S. So we'll see why we need that. So let's say we don't have that white space, right? So let's say there's no white space at the end. So for each character in S, let's say we start from the first character. From here, this character is not empty, so it will be added to word B. Then it goes to the next one. It will be added E, then S, then T, right? Now, then when we get to this white space in this else, if the word exists, if there are any characters in the word, then this final S, which is empty, would be concatenated from the left side with what we have in the word. So it would be best, and there's a white space, and there was nothing after that, right? Because it was empty string. Now we go to the word now gets refreshed. So the word is refreshed, and then the arrow goes to the next one, which is pointing out to this letter T. Now we start actually getting this technical word, right? So we keep track of these characters, we get technical, and then when we hit this white space, this technical from this line would be concatenated to the left of this plus a white space, right? And then this will go on and on. So this interview goes next. And then we get to this prep, which goes next. And then we get to these courses. And it will go, so this word becomes courses. And then on this line, it will get concatenated from this point. And then word will be refreshed. But now we are at the end, right? So if we don't have that white space, we get out of this for loop, and we never get to this conditioning here, right? So now let's see. I haven't put that white space. So basically, if there's no white space, we never get this last word in our in this final string, right? Because we never hit a white space. So this condition here will not be met. So, but if we get to this last part here, in the next round, this condition will not work because word in that case is empty. Okay. Now the last question is why we are using this -1, because we don't need this last empty space that we created. So we just want to drop that. So we will simply return this part of the string. Okay. Let's check it out. But I think you you get the gist of this solution, and then you can also try it out again. So this was a little bit tricky, but I wanted to show you how this can be done without Python functions, and this is a pretty efficient solution as well because we're just passing through these characters only once. So it should be also good on that. Any questions here? All right, so let's go to the next question. So the next question is find the first occurrence of a given character in a given string. So for example, if we're given the string, we want to find E, the first occurrence is at index 3. And here there's no N, so we will just return -1. Okay. So finding a character is what .find does, right? So if you remember from the class, we had this function .find. So we have S, which is the string, .find, and then our character. Now in this case, toFind is our character, and that's it, right? So if you cannot find that character, it will return a -1. Otherwise, it will return the index of the first occurrence of this character toFind. So I'm going to return this thing. Okay. So this is one way to do it, but even if you don't want to use, the function find here, we can simply just pass through all the characters, and then when we get to that character, we can simply return that. So if I want to show it to you very quickly, so this was our solution 1 and 2. So I'm gonna use a counter to count basically oh sorry, so no, I don't need to count this one here because I'm using a for loop. I'm going to get into a for loop and then check to see if at that index we are getting to this character. So for I in range length of S, right? I'm checking that if S at that index is equal to that particular character. If that's the case, we're going to return that index. Otherwise, if we cannot find that, we're going to return -1. Okay. So getting back to the question on enumerate, if you want to write this with enumerate, you can write for I and char or character in enumerate of S. If char has the same value as find, return I. Otherwise, return -1. Okay. So what's happening here is enumerate is giving us both index and the corresponding value. So here, instead of S at I, we can simply use char because it's the value we are trying to access here, right? So you have both options. Any questions here? Okay, so let's get to the next question. Let's see if we can wrap this up on time. All right, so the next question is count alphabets. So count the number of alphabets in a given string. So let's say we are given the string. What are the alphabets here? Is A, doesn't matter if it's lowercase or uppercase. So A, B, D, J. We also have a C here. So we have 5 alphabets, right? So in this case, we have no alphabets, we return 0. Okay, so there is a constraint here that string contains lowercase, uppercase English alphabets, digits, and some special characters. Okay. All right, so I'm going to show you 2 different ways. So first one, I'm going to go through all the characters. If they're alphabetic, then I'm going to count them, right? So starting from count 0, I'm going to go through this string. Then you remember we had a method named isAlpha, right? So we would check if the letter is an alphabet or not. So at each character, if that character dot alpha, is alpha, right? Then if that's the case, I'm going to count it. And then at the end, I'm just going to return count. Okay, so this is my first solution. And then the second way to do it is not using Python methods. So it's going to be similar. So I'm going to copy the same solution. But instead of this line, instead of using a Python function, what I'm going to do is I'm going to use the fact that English letters are also ordinal, meaning that the order, the order is defined for A to Z. So basically, if I write, let's say, A less than B, I'll get a true, right? If I write C less than B, I get a false. So I'm going to use this fact to, what is this one? Okay. So to actually get this condition, right? So I'm going to say if character is some lowercase English character, character between A and Z, or the same thing, but for uppercase, then this means that I am looking at it alphabet, right? So if this condition holds. So we have 2 ways to do this. First one using isAlpha, which is a Python built-in function. Second one, we are using the fact that English letters lowercase, and then uppercase, each separately are ordinal. So I'm gonna show you a new function here, which we are gonna use for the next problem, not this one, but we actually have two functions to map between any character in Python and some integer mapping, right? So, if, for example, if I have a, there's a function named ord, which stands for ordinal, which gives you a number for that character. So, what's interesting is, I mean, what we can actually use in this case is the ordinal of b is one after a. So if you go up to z, then you'll see that it goes one by one until 122, right? And the same thing holds for uppercase. So ord of a starts from 65, and then if you look at z, it goes up to 90. Okay. Now, you also can go the other way. So if you are given 122, you can use CHR, or getting the character of 122 gives us small z. Okay, so this could be very helpful. Actually, I'm going to use it on the next problem. So let's go see what is the next problem. Any questions here before I go to the next problem? Right, so let's go to the next one. So the next question is convert uppercase characters to lowercase. So convert all uppercase characters to lowercase in a given string. So let's say we are given this word. We're going to switch all the uppercase letters to lowercase. Okay, so both of these examples, this is what happens. And so we are given only strings of English characters. So it's not, you'll not be provided something with digits or special characters or something like that. But actually, that would also be easy to solve. You can try it as an exercise. Let's say you're given something like this, but there are some special characters like an exclamation mark, a hashtag here, and some digits at the end. So you should be able to solve this as well. Basically, it will be a combination of this problem and the previous problem. Okay, so for this one, the easy way to do it is just to return s.lower, right? So we know that lower is a built-in function in Python, and it will lower all the English characters. Okay, so that would be one thing. But the other solution, which I'm more interested in, is basically trying to build a new string. So let's say I'm given this thing. I'm going to go character by character. And then each time I'm going to find the lowercase specifically for this character without using the lower function in Python and add that to my current string. Okay, so I'm going to create a new string. So let's say new string is going to be an empty string. Then I'm going to go into this for loop for character in S. And at each step, I'm going to check to see if I'm looking at an uppercase English letter. So if I'm going to use the same conditioning that we learned earlier. So if character is between A and Z, okay. If that is the case, then our empty string needs to be concatenated with the lowercase of this, right? So some function which we're going to learn how to write lowercase, let's call that function lowercase character, right? So we need to know how to write this, but we're going to do that. And then Otherwise, if that's not the case, we're gonna just add the character to this new string, because if this is not the case, it means the character is lowercase, right? So we just simply add that, or concatenate that to our resulting string. And then at the end, we can just simply return a new string. Okay. Now, how to define this lowercase? So let's say we are given a character. So I'm going to use these functions to find a formula to go from uppercase to lowercase. So let's go with an example. So for A, the number assigned to uppercase A versus lowercase A is 65 and 97. Okay, and same thing for B. These numbers are 66 and 98. Okay, so can you notice a pattern here? So these numbers are changing, but their difference is not, right? So even if I do a Z here, still the difference is 32. This one is 32. This one, 122 minus 90, is also 32, right? So that's what I'm going to use. So this fact that the difference between these are 32 is what I'm going to use to go from the uppercase to lowercase. So if this condition is true, which means my character is uppercase, then I'm going to get the ordinal of my uppercase. I'm going to add 32 so that I get from this number to this number. And now this number belongs to the lowercase. So now I need to get back to the actual character. So I use the chr function to get back to the actual character, right? So this is a formula which gives me the lowercase of an uppercase character. So here, if I have A, it will give me a small a. If I have G, it will give me a small g, etc. Okay. So I'm going to use exactly the same equation here. And then instead of G, I'm going to put my character. Okay, so this should now make better sense. So if going through all the characters in the string, if my character is between capital A and capital Z, or basically is uppercase, then I find the ordinal of that character. I add it by 32 to get the corresponding number of the lowercase, and then I map it back from integers to an actual character. So this will give me the lowercase. Okay. If it's not an uppercase character, then I would simply add that to the end of my string. Any questions on this one? Okay, so if there are no questions, let's get to the last problem. So the idea behind the last problem is something we have already seen, so I'm not gonna go to the details of the extensive solutions. So before actually going over the question, I see there is a question on the Q&A. What other characters are between the two cases? Why 32 and not 26? So we are using 32 because the way these numbers are assigned to these characters, this is the way it works. I mean, to A, it is assigned 65 and 97. So the difference here is 32. This is not, doesn't have anything to do with that we have 26 characters. Is just the way it's defined, how we map these characters to these numbers in Python. We find what is the underlying pattern, and then from that pattern, we realize that this difference is 32. So it doesn't have anything to do with the fact that we have what number of English characters do we have. Okay, so let me actually go over this last one, and then I will stay, and feel free to ask your questions after that. So find the length of the last word in a given sentence. Okay, so let's say we are given this sentence. We know how to split this sentence into different words, but now we are going to get the last word and find the length of that, right? Even if there are white spaces before and after, we're going to remove all that and get the last word. So this is a great exercise for you to go over basically a manual treatment of how to find this last word, and then how to get the number of characters of the last word. I think you should have some ideas after this class, after one problem that we have seen already. So I'm just going to give you the easy solution, which is using Python functions that we've learned. And then you know that we can get the list of words if we use split and call it on this given string, right? So if you just do simply split, it's going to give us a list of words. And then if this list is not empty, then we can get the last word, right, by simply getting the last element of this list. And then we can just return the length of that last word. Okay. If that list is empty, then we can return 0, right? Because if we don't do this conditional statement, then this line would give us an error, because if the word has length 0, then this will return an error because there's no last element here. So this is basically the short solution, or the easy solution, using Python functions. But now you can be more creative and see how you can actually get the last word in such an example. So I can give you one hint. If you want to go backwards, I can show you how to do that in a for loop. So for I in range n minus 1, minus 1, minus 1. Okay, so this is how you can actually write a backwards for loop. This n is actually the length of sentence. You get the length, and then you want to go backwards. So you want to start from n minus 1 index. And then you want to go all the way to -1 index. Here, -1 doesn't mean the last index. It means actually the one after 0, right? And then you want to go backwards. So this is how you can actually write a for loop, which goes from the last element to the first element. And we stop at 0, right? Because the last element is exclusive. And then you can start from the last element and then see when you want to start counting and then when you want to stop counting, right? So see if you can do this on your own. I will also, I will basically attach the solutions to the same location on up level that I did last time. So you can get access to all these solutions, but I would highly encourage you not to go over them before you have actually tried it. So the best way to get the most out of this class, of today's class, is to actually sometime from now to the Sunday class, try to go over these problems on your own, both the solutions that we saw in the class and also the solutions which I gave you as exercise. Try to do them on your own, and then look at the solutions on the notebook which I'm going to provide. So that's the best way of learning and getting more comfortable with these concepts. Okay, so now I'm gonna stay for a bit to answer questions if there are any, but if you have no questions, thank you for joining, and I'm gonna see you on the Sunday class. All right, so let's go over the questions now. Okay, so the first question is, let me actually bring everything. Okay, so the first question is, do we need to trim the string first? You mean on the same problem? You can actually trim that. You can use the strip function that we learned in class, you remember, to actually trim the white spaces from both ends. But you don't have to. If you use split, it will do the job for you. So yeah. The next question is, how do we get an export of the transcripts if we wanted to pass it through Readwise into Notion or Tana? So I'm not sure about those software, but how do we get an export of these transcripts? So by transcripts, you mean these transcripts, or yeah, if you can tell me more. For taking notes, but starting from the transcript of our Zoom meetings. Yeah, so that's yeah, I'm not sure. I think you should ask operations if they enabled such option. I remember that someone was asking for the Q&A, and I asked operations, and they said, tell us that they can reach out to us. It seems like it's not the default option, so please let them know, and I think they can provide that to you. So I see there's a quick question here that during a live coding interview, is it necessary to write code comments throughout your code, or verbal explanation is good enough? Usually they're not expecting you to write comments. If you have enough time and you're done with the code, if your code runs seamlessly and everything is fine, you have optimized your code, if everything is done, then you can actually showcase that what commenting is, and you're aware of that, and you can start writing comments. But probably the interviewer will tell you it's okay, they don't need it. But yeah, it's good to show that but that is not the high priority. So the most important thing is that you come up with a working solution, and then you can decorate your code and make it cleaner. Okay, anything on the chat? I don't see any other questions on the chat here. Anything else? Any other questions? I see there's a hand raised. Sudhakar, please go ahead. Sudhakar, I cannot hear you. I see that you're unmuted, but...
Oh, no, it was an accident. But I was about to type thank you, and then I hit the wrong button.
No worries. Thank you for joining the class.
Yeah, bye.
Any other questions? Okay, so if there are no other questions, then thank you all again, and see you on Sunday.